So now let's look at the second half of those notes for section 7.2. We'll begin with problem 8. We have the cubed root of 32 divided by the cubed root of 4. Now, provided that the root that you're taking is the same, you can do that division, or if you were multiplying, you could multiply those numbers together. So since that's the case, I could reduce, since they're both under the cubed root, say that I know that 32 divided by 4 is 8. So what I have then is the cubed root of 8. I want to rewrite that 8, so I'd have the cubed root of 2 cubed, and then simplifying, taking the exponent and dividing it by the index, that would just be 2. So now let's look at problem 9. We have the fourth root of 64, so the first thing I'm going to do, I'm going off to the side, I'm doing a factor tree on the 64. Now I know that 64 is 4 times 16. 16 is 4 times 4. Now I'm taking a fourth root. This is only a 4 cubed. That means I'll need to break down each of the 4's into 2 squared. And then I can look at the bottom row of my factor tree, and I will rewrite 64 as 2 to the 6th. So I'll have the fourth root of 2 to the 6th. Now for this particular problem, there's something unique about it in that the 6 and the 4 have a common factor. So this problem might be easier to do using fractional exponents. So that's the way that I'm going to show you, because this then would be 2 to the 6th fourth power, but 6 over 4 can be reduced, so that's 2 to the 3/2 power, and when I simplify that, I will get 2 square root 2. So in simplified form, you would get 2 square root 2 for an answer. Now, I know that at this point you might say, well, wait a minute, why isn't that 2 times the fourth root of 2 squared? And you can simplify it that way, but you need to realize that since this 2 and the 4 as an index have a common factor, the exponent and the index have a common factor, you'll need to reduce that out, and your final answer must be of the form 2 square root 2. Looking at problem 10, we have the 6th root of 49. So we can rethink that 49, rewrite it, and we would have the 6th root of 7 squared. But now that doesn't contain 6 of anything. However, I notice that the 2 and the 6, they have a common factor, so I'm going to rewrite as 7 raised to the 2/6 power, which can then be reduced, so we would have 7 raised to the 1/3 power, which would be the cubed root of 7. So we can simplify even though we can't take out 6 of anything. So now let's look at problem 11. This time we have a fraction under a radical. We don't want to leave it like that. So just like with square roots, we're going to break this apart. We would have the fourth root of 2 over the fourth root of 3. Now I need to rationalize, get that radical out of the denominator. But in order to do that, because I'm taking a fourth root, I need 4 of something. I need a group of 4 underneath that radical. So right now I have a 3 to the first power, so I have 1 3. I need to get 4, so I'll need to get 3 more. So I'm going to multiply by the fourth root of 3 cubed. And what I do to the denominator, I would also need to then do to the numerator. So I'd multiply by the fourth root of 3 cubed. Now in the numerator, I would have the fourth root of 2 times 27 over the fourth root of 3 to the 4th. That gives me the fourth root of 54 over 3. Now I would look at that and say it's a fraction. I want to put it in lowest terms, but it's not possible to reduce the 3 and the 54 since one of them is located inside the radical and one of them is outside the radical. So for problem 12, a similar approach to what we did in 11, we'll break it apart. We would have the fourth root of 7 over the fourth root of 8. But now keep in mind that we can rewrite that 8. We can think of it in a different way. So we would have the fourth root of 7 over the fourth root of 2 cubed. Now again, we want to rationalize in order to get something to come out of that denominator. We're taking a fourth root. We're going to need a group of 4. Right now I have a 2 cubed, so all that's missing there is the fourth root of 2, and I only need one of them. Now in the numerator, that would give me the fourth root of 14. In the denominator, I would have the fourth root of 2 to the fourth, which would then come out, and so I would have the fourth root of 14 over 2. Again, I have a fraction. I want to look at reducing it, but I can't reduce the 2 and the 14 because one's inside the radical and one is outside of the radical. To reduce, they'd both have to be in the same spot. Moving on to 13. This time we're multiplying the roots that we are taking, cubed root in each, so because the roots are the same, we could do the multiplication. Now, some people would multiply the 20 and the 150 and then simplify by doing a factor tree on that. Generally what I do, my numbers are smaller, they're easier to work with. I'm going to do the factor tree first. So I would look at the 20 and I would say 20 is 4 times 5, and I know that 150 is 6 times 25. So I'm going to rewrite the 20. I don't want 4, I want it in prime factors, so I'll do 2 squared times 5 times, and then I'd have the cubed root. 6 is 2 times 3, and 25 is 5 squared. So the cubed root of 2 times 3 times 5 squared. Multiplying, then I would have the cubed root, and I can just add my exponents. So I have a 2 squared times a 2, that would give me a 2 cubed, times a 3, and then a 5 times a 5 squared would be a 5 cubed, so times 5 cubed. Now I can go ahead and take the exponent and divide it by the index. So a 2 gets to come out, the 3 will have to stay in, and the 5, I'll get 1 5 that can come out. So I would have 2 times 5 times the cubed root of 3, and then 2 times 5 is 10 cubed root 3, and that would be my answer. Now let's go ahead and look at problem 14. As we look at that, one of the things I notice is that what's exactly inside the parentheses is the same. And so one of the things we want to start to realize is that we're really looking at like terms. If I said that I wanted x to represent a 4 raised to the 3/4 power, then what I would have is 5x minus 3x. So I'm going to start by looking at these as like terms, and then I would get 2 times 4 raised to the 3/4 power. Now there are a couple of different ways to approach this. I'm going to go with the way that is most direct, although you could use radicals and it would be just as correct to do, just a little bit longer. I know that I can break down that 4 though. I don't have anything that gets to come out because I have 3/4. I don't have an improper fraction. So I'm going to have 2 times, and then 4 I'm going to choose to write as 2 squared, and that will be raised to the 3/4 power. So multiplying my exponents there, I would have 2 times 2 raised to the 6/4 power. But just like in the problems above, that can be reduced, so I'm going to do that. So I have 2 times 2 to the 3/2 power. So that's 2 times 2 square root 2, because 2 goes into 3, 1, remainder 1. And then outsides with outsides, insides times insides, and I would get 4 square root 2. Now remember, that's one way to do the problem. I chose to work with fractional exponents. If you're more comfortable with radicals, you could do the problem with radicals. It would just be a little bit longer. For problem 5, again we're subtracting. These are not like radicals, they're not like terms, so right now there's not much I can do about them. However, I can rewrite the 81, and so I can think of that as in a different way, and I know that 81 is 3 to the 4th, so I would have the cubed root of 3 to the 4th minus the cubed root of 3. Now the cubed root of 3 to the 4th, I can simplify. A 3 will come out, and so I would have 3 cubed root 3 minus the cubed root of 3. Now these are like radicals or like terms, and so there's really a 1 in front of that. I can combine them. So I have 3 minus 1, or 2, times the cubed root of 3. And that would be my answer. The last problem we have is a multiplication problem. We can multiply those numbers together as they are because we're taking the 5th root in each case. Now again, I'm going to do my factor trees as I go. My numbers are smaller, they're a little quicker for me to deal with. So I would have 6 times the 5th root of, and then 12 would be 3 times 4, and 4 is 2 squared, so I would have 2 squared times 3, times 7, 5th root of 24. 24 is 8 times 3, and 8 is 2 cubed, so I would have 2 cubed times 3. Now again, I chose to do my factor trees first. Some people would multiply the 12 times the 24. You can do that and do your factor tree at the end. That's fine. So now when I go to multiply, as long as the indices are the same, and they are, I do outsides with outsides. So 6 times 7 is 42. Insides with insides, so I'd have the 5th root of 2 squared times 2 cubed is 2 to the 5th. And then 3 times 3 is 3 squared. So times 3 squared. Taking my exponents and dividing by the index, I would have 42 times, and then 5 divided by 5 is 1, remainder 0, so a 2 gets to come out. 2 divided by 5 is 0, remainder 2, so the 3 squared would have to stay in, so I'd have the 5th root of 3 squared. And then multiplying outsides with outsides, 42 times 2, 84, times the 5th root, and then 3 squared is 9. So 84 5th root 9 would be my answer. So hopefully these notes help and the explanations help. Keep in mind that there are multiple ways to do many of these problems, and so you may have chosen a different route as long as you got the correct answer, and as you go through your algebra is correct, then that is fine. So good luck with tonight's assignment, and we can talk about it the next time we meet.